Transformations of exponential and logarithmic functions. All right, we're going to start with the state standards. The state standards are listed here and your success criteria. To be successful, you need to be able to describe transformations of exponential and logarithmic functions. You need to be able to graph transformations of exponential and logarithmic functions. And you need to be able to write functions that represent transformations of exponential and logarithmic functions. All right, so we have looked at transformations in several other chapters. So these should look very familiar because transformations work the same even with different types of functions. So your horizontal translation, remember that moves you left or right. Your translation is h and it's inside, it's opposite h, but it's inside your parentheses. So the -3 here moves you 3 units to the right. The +2, 2 units to the left. Remember, it's moving you opposite the way you think it's going to based on the sign. This x minus h, the negative here means it's going opposite the direction you want it to. The vertical translation, f of x plus k, this moves you up or down, and it moves you the same as the sign. Since this is a positive k, whatever the sign is, that's the direction it moves you. Plus moves you up, minus moves you down. So you can see here, we've got an exponential function, 4 to the x power plus 5, that's going to move you 5 units up. 4 to the x minus 1 moves you 1 unit down. And that's from your parent function. Remember, transformations are how does it shift or move from your original parent function. A reflection, again, remember if the negative is inside the parentheses, it's going to reflect across the y-axis. If the negative is in front of your f of x, it's going to reflect across the x-axis. And then you've got a horizontal shrink or stretch. And again, the a is inside the parentheses here. You can see this 2. If it's a shrink by a factor of 1/2 and a stretch by a factor of 2. So again, you can see it's kind of opposite the way you think. You've got to be careful with the shrink and the stretches because of just the way it works, kind of like up here where it's opposite h. So inside the parentheses kind of changes it because you're taking a and you're applying it to x, not the whole f of x. So the way it works in the function is a little different. So a vertical stretch or shrink when a is multiplied times f of x. Remember, f of x is your y value. So up here it's changing the x value, and here it's changing the y value. All right, so we got 3 times 4 to the x power. That's a stretch by a factor of 3. And this one is a shrink by a factor of 1/4. So when it's outside the parentheses, it's kind of more straightforward, kind of like the vertical translation here when it's added to f of x, which is your y value. Up here, again, this is changing your x value before you apply it to the function. Same thing here. All right, if you look at logarithms, this is all exponential stuff. These are logarithms, but it's going to be the exact same thing. Minus h is a horizontal movement opposite the sign. So -4 is 4 units to the right, plus 7, 7 units up. Same thing with k, it's up or down. Plus 3 is up, -1 is down. This one's inside the parentheses, so it affects the y-axis. In front of f of x, so it's changing the y. And that reflects across the x-axis. Same thing with your horizontal stretch and shrink. A is inside the parentheses, so it's being applied to the x before f of x. So that means it's going to be a shrink by a factor of 1/4. So it's always 1 over whatever that a is. So here it's 4, so here it's 1/4. Here it's 1/3, so it would be 3. Same thing over here. So where it was 2, and it's a shrink by a factor of 2, it's 1 over a. And then, so you can see how it works exactly the same way, whether it's exponential or logarithmic. So a vertical stretch or shrink means a is multiplied times y, or f of x, and it's a little bit more straightforward. The 5 is your stretch by a factor of 5. 2/3, it's a shrink by a factor of 2/3. And it's a shrink because it's less than 1, stretch because it's greater than 1. Same with the other functions as well. All right, remember, we've already done transformations with linear, with absolute value, with quadratics, with cubic functions. So you've already done transformations with several other types. So these are just rules. If you learn the rules, like when you learn to drive, if you learn all the rules to drive, then you're going to be a good driver. If you learn all of these rules for math, then it will make this class much easier. Example 1, translating an exponential function. Describe the transformation of f of x equals 1/2 to the x power represented by g of x equals 1/2 to the x power minus 4. Then graph the function. All right, so f of x is your parent function. And you can see that g of x is taking the same function and it's got -4. This is outside the parentheses, so this means it's a vertical translation, so it goes the same as the sign. So this tells us we're going to move down 4 units. So we're going to take the same function, move it down 4 units. If you have to graph this without a calculator, all you have to do is pick x values, make a table, pick x's, plug it in, solve for y, get 4 or 5 points, sketch the graph, and then take the exact same graph, those points, and move them down 4 units. So the transformation is down 4. So that my graph is not terrible, I'm going to use the graph provided in the book. And what I want you to notice is f of x is here. This is your exponential function of f of x equals 1/2 to the x power. If you substitute 0, anything to the 0 power is 1. That's why your y-intercept is 1. If you use -1, okay, -1 means that properties of exponents, 1/2 to the -1 means you have to flip it. So it would be 2. 1/2 to the -1 is 2. So that's why when you substitute -1, you get 2. So I'm just kind of showing you how if you made a table of values to graph points, you would get the same points. If you put 1, anything to the first power is what you started with, so that would be 1 and 1/2. And any other point you go, it's just going to be fractions. As you can see, it gets closer and closer. There is an isotope here at x equals 0. All right, so they take this f of x and they're going to shift it down 4. So if you start at 1, just use the y-intercept, it's easy. Go down 1, 2, 3, 4. So now you can see the y-intercept here is -3, but I'm shifted down 4 units. The whole graph shifted down 4. All right, so if you made a table of values for this, it would work very much the same way. You would pick x's, plug in the x's, and solve for your y values, which in this case would be your g of x values. Now, study tip, notice in the graph that the vertical translation also shifts the isotope 4 units down. So the range of g is y greater than -4. So here the range would be y greater than 0, but for g of x, the isotope shifts down with the function. Just like the whole function shifts down, so does the isotope. And remember, the isotope is the line where the graph approaches, but it never actually touches that. But that does change the range of g of x, so the range would be different than f of x. Example 2, translating a natural base exponential function. Describe the transformation of f of x equals e to the x power, represented by g of x equals e raised to the x plus 3, and then plus 2. All right, so you can see that this here would be the horizontal movement, and this is the vertical movement. So that's your 2 translations. So this is plus 3. Remember, the horizontal goes opposite. So even though it's plus and you want to move right, you actually move left 3. So it's going to be left 3 units, and this is going to move you up 2 units. So that's describing the transformation. You're going to take f of x, move left 3, up 2. It says then graph the function. So once again, I'm going to save you from me graphing it, and I'm going to get the graph from the textbook. And you can see that again, f of x is e to the x power. So this is your e to the x power function. And then we take this function. Again, I always like to use the y-intercept because it's the easiest to see. Every point's going to move the same, but you can see that it moves 1, 2, 3, 1, 2, and this would be your new, this would be where the y-intercept moved to. So g of x is just a transformation. Again, the isotope moves with the vertical movement. So when it moved up 2 units, the isotope moved from 0 up to y equals 2. So your range would change for this one as well. Now, I want to show you on the calculator. You probably already know this, but if you're graphing functions using your TI-84, it's nice to know where certain buttons are. So you can see right here is the E button. So if you want to graph y equals e to the x, so you graph y equals, oh, I didn't push the second button. All right, so delete. So you go back. You have to do second divide because the e is in blue. And then I want to raise that to the x power. And if you do that, then you can graph the function. And you'll see the function that looks like this blue line here. All right, so that is f of x equals e to the x. Then if you wanted to graph the exponential function, the transformation, g of x, you could do that as well. So we're going to graph e, and then we're going to raise that. And this time we want x plus 3. So you're going to have to put this in parentheses because this is your horizontal movement. So we're going to have parentheses x plus 3, close your parentheses, and then you have to use the arrow button to drop it back down so it's not with the exponent anymore. And then you do plus 2. So if we want to use your TI-84 to graph these, you can do that as well. And you can see that's the red line here that is graphed.